Hello everyone. Today I am going to discuss the third problem of Leetcode Weekly Contest 433, which is paint house 4. So what is the problem? We are given in houses, and we are given also three type of paints. So that is given in a 2D array, cost of size n cross 3, where cost ij represents the cost of painting house I with color j plus 1. Okay. Now we have also some constants. So no two adjacent houses are painted in the same color, and houses adjacent from the end of the row are not painted the same color. So let's say n equals to 6 and we are using zero based indexing, then the zeroth house and the fifth house could not be of same color. Similarly for 1 4 and 2 3. Okay, we have to return the minimum cost to paint the houses such that they look beautiful. Okay, I hope you get the point. Now let's take the first example, okay, where n equals to 4 and cost is this. So let's take this. Let me write it here. Okay, how we can increase the size? Okay. Oh, this is stuck. Okay, let's increase the size of this to 20 16. Okay, so n is 4 and cost is 357 629 481 and 735. Okay, so that means that if we try to paint the house, the first house with color 1, thus cost will be 3. With color 2 the cost will be 5, and with color 3 the cost will be 7. So what is the ideal solution for this? Let's check this. So the ideal solution is 1 2 3 2. Okay, so the first house is painted with the first color, that will be of 3. The second house is painted with the second color, so that will be 2. And the third house is painted with the first color, that is 1 2 3 2. The third house is painted with the third color, so that will be 1. And the fourth house is painted with the second color, it will be 2. So 3 2 1 2. Okay, the cost is 5 6 and 8, I think, right? Sorry, the cost will be 3 2 1 3. These are the paints. Okay, and these are the cost. So 3 6 8 and 9, the answer will be 9 here. Okay, I hope you get it. Now let's say you are thinking that we are taking the minimum of every possible house. We are taking the minimum from here, here, here and here. But let's say the everything is minimum, so every first element is minimum. Let's say we have three houses, the first element is minimum. So let's say the first house has 199, the second house has 11010, and the third house has 188. Okay, so we can't really take the first element every time, because we can't really paint the first house as and second house as with the same color. For here we can take the first house and third house. We can't really paint the first and third house with same color. Okay, so we have to take 1 from here and 8 from here, uh, or we can take 9 from here and 8 from here, and we can take 110 from here, sorry, 1 1 from here. So the cost will be 9 plus 110 plus 8 18. Okay, I hope you get the example explanation. Now let's think how we can solve this problem. Okay, what is the brute force way to solve this problem? Brute force way to solve this problem is to try assigning each and every color to each and every house. So we have three colors and we are trying to assign to each and every house. The overall time complexity will be order of 3 into n, 3 to the power n. Okay, 3 to the power n, and this could be solved using recursion also. Okay, now how we can improve this time complexity? Our idea will be same, but we are trying to improve the time complexity. How we can achieve that? So when this type of cases arrive, we can think about dynamic programming. Okay, so for this order of 3 to the power n without memorization, how we can solve this? Okay, so what will be the parameters? So one parameter will be our obviously the index of the house we are currently at, that let's call it I. Now what what other things we need? Okay, so whenever I will explain you my approach. Let's say we are painting some house, ith house. Okay, so let's say our house is numbered at 1 2 3 4 5 6. So let's say we are painting the second house. Okay, so whenever I am painting the second house, I will also try to paint the fifth house, because there is a constraint that the second and fifth house could not be of same color. So at whenever I am painting 2, I will try to paint 5. So that's why we have to also maintain what is the previous color, because what is the previous color house, sorry, color of the previous house, what is the color of the first house. Okay, that will be our another second parameter, so let's call it c1. Okay, now what is the next parameter? So whenever we are painting the house fifth house, we have to also have the color of the sixth house, so that let's call that c2. So previous of the current house, and we can call it that mirror opposite of the current house. So mirror opposite of the current house mi will be nothing but n minus I minus 1. Okay, n minus I minus 1. So we have to maintain the color of the I minus 1th house, that will be the color of this house, and we have to maintain the color of the mi plus 1th house, that will be the 6th house. Okay, this will be three parameters of our I, C1 and C2. The rest of the part is quite straightforward. We will iterate over each and every color. Okay, we'll iterate over all the three colors such that the color of the current house, let's call it color of the current house will be C3, and let's call the current color of the uh, mith house is C4. So our constant will be C3 could not be equals to C4. That is the first constant. The second constant is C3 could not be equals to C1. That is our second constant. And our last constant is that our C4 could not be equals to C2. So we have to iterate over every possible color combinations of C3 and C4 with checking these conditions in our code. After that, we can add memorization in the problem statement, and we can reduce the time complexity from 3 to the power n to uh, I C1 C2. We are using memorization. The maximum value of I could be n, the maximum value of C1 could be 3, and the maximum value of C3 could be 3. So our overall time complexity will be order of 9n. Okay, that is definitely possible because n is 10 to the power 5. So let's jump into the code. So this is the recursion part. So we are taking I, j, k. J and k is nothing but the C1 and C2. Now we are checking if I is greater than n minus I minus 1, that we have already come at this point. Let's say we have come at this point. Here I is pointing to 4. Then we have already painted all the houses in this part of the mirror, you can say. So that's why we'll return 0. Now this is part is the memorization. This is quite trivial. And if I equals to n minus I minus 1, this case is not required because I overlooked the this condition that n is even. So I could not be equals to n minus I minus 1. So you can remove this part. Okay. So now we'll iterate over C3 and C4. Our L is C3 and R is C4. Okay. So we'll iterate over each and every possibility of C3 and C4, and we'll check these three conditions I have already told you. C3 not equals to C4, C3 not equals to C1, and C4 not equals to C2. Okay. Now, if these conditions are satisfied, we can take answer equals to minimum of cost IL, means that painting the ith house is C3, and we are taking the mith house with C4, and the rest of the recursion. Okay, I hope you got the explanation. This is quite straightforward problem, quite straightforward DB problem. I will provide the link of the code in the description box. If you still have any doubt in any part of the code or explanation, you can always ask in the comment section. If you find this video helpful, please like the video and subscribe to my channel, and also share among your peers. Thank you.